Today we will be going over the 4 cases of oblique triangle. Case number 1, where our side A is less than the height. For these next 4 cases, we will be dealing with the same constant side length B of 8 and the same non-contained angle of 60 degrees. And here we have that our A is of length 4, which is less than the height, which is length 6. And if we draw out this length 4 and we try and drag it, we see that there is no possible way that we can create a triangle because it does not simply reach the bottom base, no matter what. And so we cannot have a triangle if the side length of A is less than the height. Now, if we try to draw this triangle, given that the non-contained angle of 60 degrees is next to the side 4, so we draw the side length of 4, and we see that it approximately reaches here, and then we have our side length of 8. We see that in this case, our side length of 4 is greater than the height, because as shown, if you drag down the height has a side length of a little over 3.5, and so this case would not apply here since we don't have that any of the sides are less than the height of the triangle. And so there's no possibility that you could draw a triangle this way. Now, if you, for some reason, cannot draw the triangle, you can test this out by using the sine law, because if you try to calculate the angle that would be across from 8, so you do sine b over 8 equals sine 60 degrees over 4, we get sine b is equal to 8 sine 60 degrees over 4, which is equal to 2 sine 60 degrees, and if we take sine inverse of this amount, we get an error in our calculator. And whenever you receive an error, that's when you know that you have made a mistake and you have incorrectly interpreted the side lengths. Now our second case is when A is equal to the height. Once again, we are dealing with the same side length of 8 with the 60-degree angle, and we have our height, which is still length 6. And we have been given that our side A is also 6 and even. So drawing it out, we see that it perfectly aligns and it creates a right-angled triangle. And this is the only triangle that can be made in this case. And we will always have a right-angled triangle. Now once again, let's try to interpret this question by using the length of A as the side with the 60-degree angle. If we draw our side length of 8, we see that the height is now, it's a little bit over 4, and so it is less than 6, it is less than 8, and it's clearly less than the base. And so we don't have that any side is equal to the height, and this case does not apply. Now our third case, where H is less than A is less than B. So once again, let's have our side length of 8 with our 60-degree angle. And we have been given that our A here is 7 because that is the only whole number that is between 8 and 6, which is still our height. If we draw out to the right side, length 7, and we drag it down, we see that we have a triangle created, an acute triangle, but we can also draw the line from the other side and drag it down, and we see that creates a second triangle. Zooming in, we can tell that this triangle is very thin and has a very obtuse angle. And then we have our second triangle as well. So we have 2 possible cases that we can have when we have that the side length of A is greater than A and less than B. And you will need usually a little bit more information in order to properly create a triangle. Now our fourth case is when A is greater than B. So here we still have that our B is 8, our non-contained angle is 60 degrees, and our side length is 12. And so here we draw our side length of 12, and if we drag it down, you see that once again we have an acute angle, and even if we want to try to do this from the other side, we see that we cannot have a second triangle because we cannot create a side length of 12, and so we only have one possible triangle to be made in this case. So these are our 4 cases of oblique triangles. Please refer to our video in the next lesson on trigonometric signs and solving for an angle.